Hello guys, welcome to my channels. Today let us continue semester 1 engineering previous year model paper. I am Asra Nazneen from S.D.V Academy. Now this is the first question. Find the extreme value of the function. Okay, let this function, consider this function as a f. So we have to differentiate it. Dou f by dou x gives the value here 2xy minus 6x. Okay, dou f by dou y gives the value x square minus 4y minus 4. Okay, now take 2x common, y minus 3. Okay, now when x is equals to 0, the value of y is 3 here. Okay, when x equals to 0, substitute 0 here. This value becomes minus 4 by 4, minus 4y minus 4. Okay, this equals to 0. Y value will be minus 1. Now when y is equals to 3, then the value of x will be x square minus 12 minus 4. Okay, x square minus 16. X is equals to plus of minus 4. Okay, so what will be the critical point here? Critical point will be 0 comma minus 1 and 4 comma 3 minus 4 comma 3. Okay, now again differentiate this. Dou square f by dou x square gives the value here 2y minus 6. Okay, dou square f by dou y square gives the value minus 4. Again differentiate dou square f by dou x dou y. From this what the value will come? 2x. Okay, now let this function be a, let this function be b, and let this function be c. Okay, now these are the critical points we have. Okay, so we have to take d, this is, that is equal to ac minus b square. Substitute this critical point here, 0 comma minus 1. When you substitute this value in this, gives the value here 2 into minus 1 minus 6, that equals to minus 8, which is less than 0, and 2 into 0 gives the value 0. This is minus 4. Okay, this a value is less than 0 here. Now when you substitute these values here, minus 8 minus 4 minus 0, which gives the value here 32, which is greater than 0. So here we have local maximum point. Okay, when you substitute 4 comma minus 3 here, so 2 into minus 3 minus 6 gives the value minus 12, which is less than 0, and 2 into 4 gives the value 8. When you substitute these values in this equation, gives the value here minus 12 minus 4, 8 squares, that is 64 here. So what you will get the value here? 64. 64, that is equals to minus 16, which is less than 0 here. So okay, this value is less than 0 and this value is less than 0. So this is the saddle point. Okay, when you substitute this critical point 4 comma 3 here, what you will get the value here? 2 into 3 minus 6, 6 minus 6 gives the value here 0, and 2 into 4, that is equals to 8, and this is minus 4. Okay, now when you substitute this value here, AC, this value is 0 and this value is minus 64, which is equals to minus 64, which is less than 0. So here this is also the saddle point here. Okay, these are the saddle points. Only 0 comma minus 1 is local maximum point. Okay, comes to next question. Consider cos inverse y by b, that is equals to log of x by n whole power n here. When you differentiate with respect to x, this value becomes 1 by root of 1 minus y square by b square into 1 by b into y dash. Okay, and this value becomes n by x. Okay, when you remove the root, this value goes up b by root of b square minus y square into 1 by b y dash equals to n by x. This b gets cancelled out. So this value becomes y1 by root of b square minus y square equals to n by x. Now do squaring on both sides. This value becomes y1 square by b square minus y square equals to n square by x square. Now do cross multiplication. This value becomes x square y1 square equals to n square into b square minus y square. So differentiate with respect to x. This value becomes y1 square 2x plus x square 2y1 by 2 equals to minus 2y1 into n square. Take 2y1 common and cancel. Gives the value xy1 plus x square y2 equals to minus n square y. Now this whole value becomes xy1 plus x square y2 plus n square y equals to 0. Apply Leibniz theorem. This value, the formula is d power n into uv, that equals to unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus and so on. Okay, now apply this equation for this, okay, which gives the value here xy1. I am applying for xy1. This gives the value y1 into nx plus y1 n minus 1 into n. That implies yn plus 1 into x plus yn into n. Now for this value x square y2 gives the value y2 n x square plus nc1, which gives the value n. So I am writing directly n into y2 n minus 1 into 2x plus nc2, which gives the value n into n minus 1 by 2. This value. So I am writing directly n into n minus 1 by 2 into y2 n minus 2 into 2. This 2 gets cancelled out. And for this n square y, okay, this value is n square yn. Okay, add these equations 1, 2 and 3. Add these equations, you will get, now here what this value becomes y n plus 2 into x square plus n into y n plus 1 into x plus n square into yn minus n into yn plus yn plus 1 into x plus n into yn plus n square yn equals to 0. Okay, so here plus ny minus ny though cancelled out. X square yn plus 2 plus 2x n yn plus 1 plus x yn plus 1 plus 2n square yn equals to 0. So okay, when you take common from here, gives the value x square yn plus 2 plus 2n plus 1 yn plus 1 plus 2n square yn, which is equals to 0. Hence proof. This is the required answer we have. Okay, this is the required answer. Now comes to next question. Now consider this question: 1 plus I whole power 1 minus I. Okay, now this can be written as root 2 e power I pi by 4. y, this is the magnitude, so root 1 plus root 1 gives the value root 2, this the value root 2, and pi by 4 means tan inverse 1 by 1 gives the value here tan inverse pi by 4. Okay, so this pi by 4 comes like this. So now whole power 1 minus I, so this can be written as root 2 1 minus I e power I pi by 4 power 1 minus I. So this can be written as, I'm calculating this value, so root 2 whole power 1 minus I, so this can be written as e power 1 minus I into L log 2, that can be written as e power log 2 log root 2 minus I log root 2. Okay, so this can be written as root 2 into e power minus log 2 I by 2. Why root 2? This power is log root 2 can be written as log 2 power 1 by 2, so this can be written as 1 by 2 log 2. So this log 2 I'm writing like this. So the whole value becomes here root 2 e power minus I log 2 by 2. Okay, now for calculating e power I pi by 4 whole power 1 minus I, so this value can be written as e power 1 minus I into I pi by 4, that can be written as e power minus pi by 4 plus I pi by 4. So this is the value of e, so e power minus pi by 4 into e power I pi by 4. So 1 plus I whole power 1 minus I gives the value here root 2 into e power minus I log 2 by 2 into e power minus I pi by 4 minus pi by 4 e power I pi by 4. Okay, now here e power I log 2 by 2 into I pi by 4, this can be written as e power I pi by 4 minus log 2 by 2. Okay, now so 1 plus I whole power 1 minus I gives the value root 2 e power minus pi by 4 into e power I pi by 4 minus log 2 by 2. Okay, which is of the rectangular form. Okay, so take as e power I theta means cos theta plus I sin theta. So here what is the value of theta here? This can be written as e power I pi by 4 minus log 2 by 2. So this can be written as cos pi by 4 minus log 2 by 2 plus I sin pi by 4 minus log 2 by 2. Okay, this can be written as 1 plus I whole power 1 minus I, that equals to root 2 e power minus I pi by 4 into cos pi by 4 minus log 2 by 2 plus I sin pi by 4 minus log 2 by 2, which is the required answer we have. Now here solve, come to this problem, solve x power 10 x power 8 power 5. Now solve this question. Now let us consider, let x power 5 is equals to y. Okay, so this equation becomes y square plus 8y plus 15 equals to 0. So find the roots. Y is equals to minus b plus or minus root of b square minus 4ac by 2a. This gives the value here minus 8 plus of minus root 64 minus 60 by 2, that equals to minus 8 plus of minus root 4 by 2, which is equals to y is equals to minus 8 plus 2 by 2, which is minus 3, and y is equals to minus 8 minus 2 by 2 gives the value here minus 5. Now y is equals to x power 5. So x power 5 is equals to minus 3 and minus 5 here. So what is the value of x? X equals to minus 3 whole power 1 by 5. So and this value minus 5 whole power 1 by 5. Okay, the roots of the complex roots are k is equals to the roots of complex roots. K is equals to mod k into e power I pi. Okay, then the argument of negative number, the argument of negative number is e power I pi plus 2n pi by 5. Okay, the argument of negative number is so the general solution is, this general solution is x is equals to mod k into 1 by 5 into e power I pi plus 2n pi by 5. Okay, so where the value of n is 0, 1, 2 and so on. So take x power 5 is equals to minus 3. Okay, so x is equals to minus 3 whole power 1 by 5 here. So mod k value is 3 and mod k whole power 1 by 5 value is 3 power 1 by 5 here. So x value will be 3 power 1 by 5 into e power I pi plus 2n pi by 5, where the value of n is 0, 1, 2 and so on. So take n value is 0. X naught value will be 3 power 1 by 5 into e power I pi by 4. X1 value is, n value is 1. So 3 power 1 by 5 into e power I 3 by 5. E power I 3 pi by 5. N value is 2. X2 value will be 3 power 1 by 5 e power I 5 by 5. And x3 value will be 3 power 1 by 5 into e power I 7 pi by 5. X4 value will be e power 1 by 5 e power I 9 pi by 5. Okay, when you take, similarly when you take the value 5 here, when you take x power 5 is equals to minus 5, so this value becomes x power 5 is equals to minus 5 whole power 1 by 5 here. Okay, now so k value will be 5 power 1 by 5. So x power value will be 5 power 1 by 5. So put the values 0, 1, 2 and remove, and this value becomes 5 power 1 by 5, 5 power 1 by 5 equals to 5 power 1 by 5, 5 power 1 by 5, 5 power 1 by 5. So this is the roots for x power 5 is equals to minus 5. Okay, which is the required answer we have. Consider the formula sin h inverse x gives the value here log of x plus root of x square plus 1. Okay, this can be written as sin h inverse tan theta is equals to log of tan theta plus root of tan square theta plus 1. So this can be written as tan square theta plus 1, that equals to secant theta. So this can be written as log of tan theta plus secant square theta under root gives the value only secant theta. So secant theta. Okay, now take the LHS value. So take the LHS value here, log of tan pi by 4 plus theta by 2. This can be written as tan pi by 4 plus tan theta by 2 by 1 minus tan pi by 4 into t tan theta by 2. This can be written as 1 plus tan theta by 2, 1 minus tan theta by 2. This can be written as tan theta by 2, that equals to 1 minus tan square theta by 2 tan theta, which is the required answer we have. Consider this is the given matrix. Now we have to write the matrix in this form: 4 2 12, 3 4 14, 1 2 5, 6 2 16. Okay, now in this matrix, divided by this row by 2 and this row by 2, you will get the 2 1 6, 3 4 14, 1 2 5, 3 1 8. Okay, now do the operation as 2 into R2 minus 3 into R1, 2 into R3 minus R1, and 2 into R4 minus 3 into R1. Okay, when you do this operation in the matrix, you will get, when you do all the operation, you will get the matrix 2 1 6 0 5 10 0 3 4 0 minus 1 minus 2. Again, divide this column by 2. You will get the value 2 1 3 0 5 5 0 3 2 0 minus 1 minus 1. Okay, now divide this column by 5 and add to R4. Okay, you will get the values like 2 1 3 0 1 1 0 3 2 0 0 0. Now R3 minus 3 R2 gives the value here 2 1 3 0 1 1 0 0 minus 1 0 0 0. Okay, from this R1 minus R2, do R1 minus R2 gives the value 2 0 minus 1 0 1 1 0 0 minus 1 0 0 0. Now when R1 plus R3, when you do R1 plus R3, you will get the value here. You will get here 1 0 0 0 1 0 0 0 minus 1 0 0 0. Okay, take minus 1 common. You will get the values here 1 0 0 0 1 0 0 0 1 0 0 0. Okay, this is the normal form of the matrix, and here what is the rank here? Rank is equals to 3. 3 is the rank of this matrix. Okay, hence proved. Hence, please like, share, and subscribe. If you had any kind of a doubt, please comment me in the comment section. And thank you, and have a nice day.